What are tensors? Hard to explain. Now, I have a lot of mathematician friends on this platform, and they could probably do it better than me. But as far as it applies for science, check out my little friend here. You could define my little friend in his position by his length, his width, and his height. You could also define his position by how diagonal he is this way, and how diagonal he is going up that way, but he's still in the same place. You could also define him as how turny he is this way, and how turny he is that way, but he's still in the same place. No matter what description of where he is we want to use, my little friend here is in the same space. And because of that, if we use one system to describe where he is, like length, width, height, and then change that system to diagonals, we can predict what that change will be because his actual position never changes. Essentially, we could use one set of coordinates to predict a second set of coordinates. That is sort of what tensors are. I mean, in practical use, they are way, way, way more complicated than that. But they're really useful for things like general relativity, where you may have to describe where something is in curved spacetime. And if you look at spacetime as kind of having a coordinate system, and mass and gravity bending that coordinate system, you are basically changing the coordinate system. Which is a lot like what I did with my little friend here. I went from these directions describing him to these directions describing him. And so, because of that, tensors are really useful for describing how space-time behaves and how objects behave in them. And if you want me to show you some examples of math with tensors, screw you, I'm not getting paid enough.